Now, where were we before the fire? We were,
Geometric series.
yes, geometric series, and we were getting straight, getting ready to discuss all the things that we have done. Now, somebody tell me what makes a geometric series, or excuse me, what makes a geometric sequence a geometric sequence?
So,
A sum, what is it?
a geometric series is a sum of section of geometric series.
Okay, the geometric series is a sum of a part of the sequence, okay? But what makes the biggest difference between, or what is the difference between a geometric sequence and a arithmetic sequence?
In geometric system, we multiply or divide to get the next ratio.
Yep.
And for arithmetic sequence, you add and subtract.
Correct. The difference is the geometric sequence, to get the next term, we multiply each of the previous terms by a common ratio. In an arithmetic sequence, we add or subtract, or add a negative, whichever way you want to think about it, a common difference to each term to get the next term. Okay? So those are the differences. And we went through and we found a specific nth term, whatever, or I gave you, say, the 7th term and the ratio, you found the first term. Or I gave you the 7th term and the 13th term, you found the first term and the ratio. We did all of that the other day. Yes? Now, the way it started, I don't know, I can't remember, because I got this class mixed up with my other one. Yes, I was going to give you the quiz, but we also started talking about our sums. And I gave you two formulas for the sum of a geometric series. Yes? What's the result? Okay, why are there two?
One more ratio.
When they both give us the same result, no matter which one we use, no matter which time. But the one on the top, because the ratio is bigger than 1, we don't have to worry about the oddball negative. The one on the bottom, same thing. If it's less than 1, then we need to use that. All right? Then we had a couple problems. All right? So your work the other day was to work through these. How far did we get?
Like
Some of them were hard.
Yeah.
Okay, which one? The last two?
One game.
Which one?
The last, the second one.
This one here?
Yeah, it was like, yeah, it was.
Talk about the geometric sequence for the heating switched off.
C.
Okay, all right, so we'll start here. Let's see if we can get anywhere with these. But yes, while two of you work together to see if we can come up with or compare what you did. See if we can help each other come up with those answers while giving back the arithmetic quiz.
Oh, no, it's just.
Mr. Easter,
Yes,
how do you do 2A?
I promise we'll go through that in a second.
Think you promise, or if it comes to me and do it.
Oh. Creepy.
I know, but I'm a picky person.
You're a picky person. Alright. Alright, so let's take a look at this and maybe one of the other ones, then we'll jump back and I promise I'll go through all the problems on that arithmetic quiz. So this one, we have the geometric sequence has the second term 15, fourth term 135. Write down the values of use 1 and r. Well, if I give you the second and the fourth term, what can I do? I can find the common ratio and I can find the first term. How?
Well, you know that the distance between U2 and U4, there's two distances or two ratios. So I divided by.
And we do that for geometry. Don't mix that up with an arithmetic. We can find that, we don't want to difference, remember, differences, those are arithmetic. We don't want to count those distances.
But it's on the same.
We're going in terms,
Right.
okay, but we're finishing, and then we'll see if you're
I was just gonna say, I wanted to find like, the combination between each terms of U2 and U3 and U3 and U4.
Okay,
So,
okay, all
I
right.
did divide, but if that's not how you do it.
All right, so there it is. Maybe my fault, I cut you off too soon. So how'd you set it up?
I just did, actually, yeah, 135 minus 15 to find U3.
Remember, we don't want to subtract, anytime we're subtracting.
U3, we don't know what U3 is, there's
Right,
a
so
position.
we don't want to subtract. What I could do is that I know that U sub 3 over U sub 2
Equals 135.
has got to equal U sub 4 over U sub 3. I can do that, and I can find the third term this way. I thought that's where you were going to go.
Wait, that's,
Okay? Because out of these four positions, how many of these positions do I know? I know 2, but what do you know about the other 2? They're equal to each other. So I could plug in U sub 2 being 15, so U sub 3 over 15 is equal to 135 over U sub 3. So I could do this, right? Now, once we do this, we have U sub 3 squared
right.
is equal to 15 times 135. But what's 15 times 135? 2025? Now, that's not U sub 3, that's U sub 3 squared. So what do I have to do? Take the square root of that. So what's the square root of 2025? 45? Well, now, we know that we have U sub 2 is 15. U sub 3, 45, and U sub 4 is equal to 135. Now, I could do this, and that's fine. What do I do now? Because this doesn't give me U sub 1.
You are.
We find out.
I can find the R, because now I can plug in.
You 45 divided by 15, you get 3. Which is.
So we can say that my ratio now is 3. Now, I think somebody over here said something different. Did anybody find this ratio different? How'd you set yours up?
I need two equations.
Same way we could do the other day, we could make 2 equations. What equations would those be?
One would be U1 is equal to 15 R and U2 would be 135 is equal to.
Hold on one second, what's that?
The first one would be 15 is equal to U1 into R.
Okay. 15 is equal to U sub 1 over R.
No. Times
Times. Okay. U sub 1 times R.
And the second one would be 135 equal to U sub 1 into R cubed.
Okay, all right. From our nth term, our general term, well, what good does this do? What can I do with these? Like we did the other day, I can rewrite this for either U sub 1 or R. It doesn't matter. Probably easier for U sub 1 since we have both of these right there. Okay, for U sub 1 in this case, so this would give us 15 over R is equal to U sub 1. Well, what can I do with that? If that's use of 1, I can take it and plug it in down here, so 135 is equal to 15 over r times r cubed. Well, that cancels out with one of those. So 135 is equal to 15r squared. Divide by 15, how many times is 15 going to 135?
9.
How many?
9.
9? And what squared is going to give you 9? 3. It's actually plus or minus 3, but I can rule out which one. Why? Not just because it's a ratio. Can I rule out -3?
Yeah.
How? Now, the problem is that I gave you an even term and an odd term. Okay? Because if I solve it this way, if I take a positive, multiply it by a negative, my use of 3 will be negative. But then when I take a negative and multiply it by a negative, it'll be a positive. This actually, if they give you 2 even terms, as long as you follow everything else using the correct thing, you can use positive or negative if you solve it this way. Okay? Now, if we did it this way, then you don't have that negative. We don't have to worry about that. Okay? So it's not that one gives you a better result, it's that you can use either. You will not be penalized for either one.
So the actual R equals
In the mark scheme, you would say, there would be 2 results. One for the positive R value and one for the negative R value. Now, the way to get around that, if you saw this on an exam, is one would be even and one would be odd. Because then, hopefully, they would work this through, realize that one method would give you a potential of 2 results, both of which are good. Okay? Sometimes they miss that. It's okay. In this case, they probably did because I stole this problem right from the book. Okay? So, but it's okay because it's something to talk about. Right? So either way, it doesn't matter. As long as we do one, we do not need to do both. We have an R value of 3. Well, great. If we have an R value of 3, what's my use of 1 value? How'd you get 5? Take it back in here. 15 divided by my R value of 3. 15 divided by 3, use of 1 is 5. Okay, so now we have R value 3, use of 1 value 5, calculate the sum of the first 16 terms. I use my sum, which is the what formula?
S and is U1 bracket R entire minus 1 bracket and minus 1.
1.
Oh, it's N. Oh,
Is that it?
and then divide by R minus.
R minus 1? Does that match what we have? Cool. Is that okay? Excuse me, can we use that one? Well, if we're going to go by this, we say, okay, well, our R value is 3, 3 is greater than 1, so I can put this, so that's R d n minus 1 over R minus 1. Yeah, that's the right one. Now, could I use this one? Yeah, there's nothing saying that when R is greater than 1, you have to use this one. Okay? As a matter of fact, like I said, this part right here is not in your formula sheet. These 2 pieces are, but this part is not in your formula sheet. Because this part where it says when R is greater than 1, when R is less than 1. Because this is just written as one extended equation. Okay? So it doesn't matter. The thing that you have to be careful though is be very careful with your arithmetic, carrying the negatives. If you follow this rule, the algebra takes care of the negatives. That's all. Okay? All right, so now that we verified that we have the correct formula, now we can take a look at this and say, okay, calculate the sum. Well, now I just plug in the bits and pieces. So the sum of the first 16 is equal to u sub 1, but that's 5, times R3 to the 16th minus 1 over 3 minus 1. Now, the beauty of this is just put this on your calculator exactly as it is. Don't try to carry things on. Okay? When you do that, you open up yourself to a potential of a mistake. Okay? So if we put all this right into the calculator as it is, bang it out, hit enter, what do we get?
107,616.
107 million?
116,800.
Woo! Pretty good number.
No, 600.
660. Pick up your number. Okay. Agreed? All right. Now, what do you notice? Do you notice anything about the sum of an arithmetic and the sum of a geometric? Geometric gets much bigger, much faster. Okay? Because, why? Because we're multiplying. Because in an arithmetic, we're simply adding. All I'm doing is adding. In the geometric, it's either going to get exponentially bigger, a lot faster, or exponentially smaller. Okay? It's going to go to the extremes much faster. Okay? So just, it's nothing, you're never going to be tested on that. It's just a little behind the knowledge there. Okay, now, give your answer of part B to 3 significant figures. Oh, man, you're going to go all the way back to 6 figs. Okay, so 3 significant figures. What is that thing with 3 significant figures? What's my rule for significant figures? Grown and
Is it a point? Is it the after decimal point?
Careful, significant figures don't necessarily, they're not dictated by the decimal.
Zero between two
other digits is a significant number, but if behind that you don't know the digits.
Okay, a 0 between 2 digits is significant. A 0 after and on down the line is insignificant, or I think that's what you might be trying to say. To the left of the decimal, the only thing to the left is 0, then that's insignificant. Okay, well, great. Where do I go? What's that? The highest numbers, how many? 3?
Well, the rest of the
So I only go to the third one?
No, you go to the fourth one to see where you keep it.
Yes. We want 3 significant figures, but the fourth one is the one that's going to dictate what happens to that third one. So we really have to go to that fourth one. And yes, this 0 is locked between 2 digits, so it is or is not significant. It is. So we got 1, 2, 3 significant figures. But this guy is the one that dictates what happens to, that's not here, sorry. That guy is the one that dictates. Well, it's a 6. Now I go to my rounding group. What goes up? Goes
Jump to 8.
to 8.
up to 8. So this 2, 3 significant figures is what?
178 times
100 what? 108 million. Okay? Whoops, wrong place. 108, 0, 0, 0.
It's a GDC.
GDC. What does GDC stand for? Graphics Display Calculator. Okay? So, when it says write down all the numbers on your GDC screen, write down all the numbers on your calculator screen. Boom, there it is. Now, take this, convert it into 3 significant figures. We said we want these 3, but that one dictates where we go. Raise that 7 up to an 8. Now, for part D, take what you did in part C and now write that in, you guys are probably comfortable seeing that in scientific notation or what they call standard form. Okay? How many of you guys know how to do this with a calculator?
You can do it, right?
That's impressive.
Your calculator does this.
Oh, yeah,
Very nice.
second E.
Second E.
Ah, even better than that.
Oh, that's something.
If you hit the load button on your calculator, all you have is TI-84s. You would have to go into, where's the
Then there's a sign.
I think it's under menu.
And then.
Okay, so you go into the mode, and where it's probably highlighted norm,
Yeah, I got it.
and then it says SCI and then ENG. Go SCI, okay? It's another English. It's actually, but, so now, if we take that, all you have to do now is if it's in SCI mode, type in this number.
1.08 E.
It will convert it to 1.08 e to the 8, which means 1.08 times 10 to the power of 8. Okay? So, just a quick cheat to use your calculator to check. Yes, you could, because anytime we want to move the decimal point to the left, we have a positive number. Anytime we want to move the decimal to the right, it's a negative exponent. So we move it 1, 2, 3, 4, 5, 6, 7. Whoops, this one, kind of twice. Sorry. This one goes there. There. Sorry. Count it. Count my comma has a digit. Okay. So we move it over 8 and we get 10 to the 8. So you can either use a paper pencil, or if you have a brain fart, use your calculator. Okay? All right. Questions about this one? Was this the part that gave you an issue? These last two? Okay? Because we did that a very long time ago. We have to remember. Okay? Okay. I'll leave it up to you. Do you want to do another geometric, or do you want to go over your quiz? Quiz?
Yes. Just got one question.
Yuri,
This?
Yeah.
Okay. Real quick, we'll go through this. Okay, consider the arithmetic sequence. Oh, and the marks, I'll explain those marks in a minute, just kind of disregard them, the ones that are in purple. Consider the arithmetic sequence, there it is, find the value of the common difference. All we have to do is take the second one and subtract the first one. Now, some of you guys did the first minus the second, you got a positive 5. Remember, that if I have a positive 5, what do I know about my numbers in my sequence? What are they going to do? They're going to go up with a positive number in an arithmetic sequence. What's going to happen with a negative number? They're going to go down. So a quick easy check, my numbers are descending, so that better be a negative difference. Okay? All right, calculate the sum of the first 10 terms of the sequence. Well, if I need the sum, I need the first term and the difference, and that last term, well, that last term is that 191, or excuse me, not the 191. I had to find that 10th term or use that, and we go on, we put it into our formula. Sorry, I had myself. Find that out to get 3,035, right? That's the sum of the first 10. Now, I had to come back to this for part C and says, okay, how many numbers are there in the sequence if it starts at 326 and ends at 191? That's my nth term, 191. So now it's 191 is equal to the use of 1 plus n minus 1 times that difference, right? And you get 28, all right? Some of us made a mistake in the difference, but they're calculating the sum and the finding the number of terms, you use that difference correctly, so you got your ECF, okay? As long as you calculate those without any additional errors. The next one. All right, the next one, the easiest one to do, All right, arithmetic sequence, fifth term, and that's, I apologize again, the subscript for whatever reason didn't come out. The fifth term, use of 5 is greater than the first term, use of 1. Difference between the terms is 36. So if I take the fifth term minus all the differences in the first, so that's 1, 2, 3, 4. I take that difference, 36, and then divide it by the number of differences, which gives me 9. Okay, so my common difference is 9. And I know it's positive because my fifth term is greater than my first term. My sequence is going up, so I know it's a positive 9. Okay? Now, this one threw a bunch of people off. Okay? Write it in terms of use of 1 and D. All right? What that means is take this stuff. If the 10th term of the sequence is double the 7th term, yes, u sub 10 is equal to 2 times u sub 7. A lot of you guys had that. That's perfect. But now, take this and put it in terms of u sub 1 and R. Excuse me, D. U sub 1 and D. So that means take u sub 10 and use my generic term and put it in terms of u sub 1 and D. That's u sub 1 plus 9D. We'll then take my u sub 7 and put that in terms of u sub 1 and D. U sub 1 plus 6D times 2. You could have left it here, or you could have multiplied that out, and you could have gotten this. Okay, so these are the two that we're talking about. It's okay, right? It's not super detrimental if you mess this up. It was very common if this an odd way to write this. You don't see this style much very often, but it does pop up every once in a while. It's good to know how to do it. Yes. So what is it's this? It's either one of these. So for part 1, it's either one of these. It would have been 5 to the here, which is u sub 10. U sub 10, because u sub 10 is u sub 1 plus 9D. U sub 7 is u sub 1 plus 6D. So then what I gotta do is I gotta take this, plug it in here, u sub 1 plus 9D is equal to 2 times u sub 1 plus 6D, and leave it, okay? Because I've substituted in these values, and leave it here, or distribute this, and get u sub 1 plus 9D is equal to 2 u sub 1 plus u sub 1 plus 12D. Now you could have took it a step further, get your u's on one side, your d's on the other side, and that's fine too. If you did that, you would get, what's that, negative 3D is equal to u sub 1. Okay, if you took it to that level, it would have been that. Okay, this one was a common mistake. Almost everybody has that. Okay, because it's, again, something unfamiliar slightly. We're not used to writing things in terms of something else. Okay, again, not a super common problem that's going to pop up, but occasionally it does. And now you know how to do it. Good thing is, it didn't crush you. Okay, I knew that it was a slightly different problem. No worries. Now, u sub 1. Find u sub 1. Okay, well, if I know these, how do we do this? Well, I take my values. I went back up to my sequence, the information they gave me in my sequence, and I'm able to get this. How am I able to get this? Well, we found the D. D's 9. Well, 6 times 9 is 54. 9 times 9 is 81. So now I take those pieces and I plug it into what I just did, and I get a u sub 1 value of negative 27. Okay. Biggest common mistake here, negative. Okay, be careful with your. So far, so good. a lot of simple mistakes. There was nothing major on this quiz. You guys did really well on the quiz. So, you know, I'm just pointing out some of the minor things that were very common. All right, 3A. Got another sequence here. All right, this sequence we say u sub 1 is 145, u sub 5 is 113. Well, it starts at 145, it goes down to 113. I know my difference better be negative. So I say, okay, well that's 1, 2, 3, 4. Find that difference, divide by 4, and we get negative 8. Well, I'm going to use that negative 8 to find the nth term, u sub n. Well, excuse me, don't find it. You give it to me. It's negative 7. But u sub n is equal to u sub 1 plus n minus 1 times d. Put those values in. And I bang it around because I know u sub 1 is 145. Put them all in, and I get 20. Some of you guys, again, arithmetic, you left off a negative or you added one in, and you ended up with a negative 20. You did all the other parts right, but you had a negative 20. Just a quick check. Can we have a negative number of terms? No. So just be careful if you come up with that. If your n ever is negative, you know that you added an additional negative in there somewhere. So be careful. Go back and check. Okay, last one. I think everybody did pretty well in this last part. For the most part, I should say. Find the sum of the first 20 terms, n divided by 2, 2 times u sub 1 plus n minus 1 times your common difference. Bang all that out, 1,380. Now, yeah, some of these there are slightly different ways to do them. It's okay. The purple marks are essentially what would correspond to ID marks. I wrote them slightly different than what we would do. IB kind of builds it up with A1s and M1s and all those. I wrote the opposite. If you miss an accuracy, it's easier for me to add those things up. So that's where those are. If you have a question about where that mark came from, why you didn't get it, please let me know. Again, on the front side, the purple mark out of 18 is just to give you an idea of what that would be out of the total marks. It absolutely means nothing as far as that letter grade. Okay? To calculate that letter grade, I looked at what you did. Specifically, if it was a reoccurring error that you did, if it's a reoccurring arithmetic error, I didn't penalize you 3 or 4 times. It's the same error. So that's, again, standards. It's hard. Fair enough? Awesome.
Does the student have anything else?
No, we're just going to do arithmetic, geometry, terms, and solids. That's it. So, that being said, we are almost done. Done, Zara. Yes, we're going to have a test very soon. I don't know, next slide.
You need to switch first.
Let's see. No, the next class that we have, I will do a geometric, because I don't think we're going to have time to do geometric sequences and series quiz today. So we'll do the quiz next class, and then the assessment to follow. We'll do the quiz in the second. Okay. We'll have it hopefully done before. The next piece that we're going to do after this is your descriptive statistics and 2 variable statistics. And once we're done with those, then you have all the stuff that you really need to do behind it. And I doubt very seriously any of you guys are going to use calculus and that. Okay, now some practice. What I want you guys to do: summing geometric series. Okay, find the sum of the following geometric series in given terms. Okay. And we're gonna do some application of these terms.
In the next 2 years.
Would it be better if I uploaded this to your Google site?
Yeah.
See. Yes? All right.
I think you guys are pretty like moms.
Yeah, and then I'm also going to at the same page. I said that movie, I think it's
I think I would say
All right, should be up there now. So you can, if you need to, you can print or whatever.
You read the morning news. Morning voice.
Oh, sure.
Until the ICR is using it together. And then I'll have the same conclusion.
Just keep us doing anything except.
Okay, some of you guys asked to see the morning bulletin. As soon as it comes out, maybe. Here we go. All right, first service learning, some of you guys know where you're going, some of you guys don't, you should know all these. CRP is right here. Oh, they actually changed the CRP here. Okay. Seniors, make sure to meet with Mr. Gerder off your advice. Let's make this happen this week. We're looking for 100% senior participation. I assume you know what that means?
Yeah, it's for Jimmy. No. I do what you do.
Peer facilitators, Pony Dance for high school tomorrow. Get up there, shake your groove thing, get it on. Okay. Your students are Spanish, grade 12 at Inicio.
Students are like how it's so good.
Laughing because Nina didn't get my joke in.
I don't get it.
I'm Googling
Can you
this.
tell them
You're joking. Can you be safe?
What was the joke?
Wait.
You.
hold on.
Go up.
Oh, I'm sorry.
You should have screamed.
Oh,
Did
yeah.
Sky
Fine, that's-
Yes.
What is the joke? Thank you, done reading.
You good? Okay.
What was the joke? Yeah.
Spanish definition, that was the joke. Oh, I think.
It's so good question.
Sophie, is this you? Your birthday? Coming up?
They didn't put my birthday.
Yeah, how old is you?
I'm
I'm like so ancient now.
Yeah? It's done?
It's not even Google Translate.
All right. Well, happy birthday anyway. Fine.
We should have so everyone excited. Like, Mr. Gizmo, you